Hi students, in the last video we discussed about stock replenishment strategies. In this video we will learn about the definition and importance of safety stock and how to calculate safety stock. So let us first understand what safety stock means. Safety stock is additional inventory that is held to mitigate the risk of stockouts, which can be caused by uncertainties in supply and demand. Calculating safety stocks helps businesses ensure that they can meet customer demand during fluctuations without overstocking the inventory. What is the importance of safety stock? Number one is the buffer against variability. Safety stocks kind of provide a cushion for unexpected increase in demand. Second is that it mitigates supply chain disruptions. It protects against delays from suppliers or logistical issues. And third is that it enhances customer satisfaction. Since it helps to avoid stockouts and ensures timely fulfillment of orders, it ensures that customers are satisfied with the service. Let us see what is the formula of safety stock. Safety stock is Z into sigma into under root L, where Z is the z-score, sigma is standard deviation, and L is lead time. If you are confused about these terms, don't worry, we will discuss these terms in the upcoming slides. Let us first understand what is standard deviation. Standard deviation is a way to measure how spread out or varied a set of numbers is. Standard deviation helps in understanding variability. In businesses, it can show how consistent or inconsistent sales are over time. Let us try understanding this using an example. Imagine you have the following test scores from a group of 5 students. Scores are 80, 82, 85, 78, and 75. Step 1 in calculating standard deviation is to calculate the mean or average. You add the scores together and you divide by the number of scores. Hence, the mean or average is 400 divided by 5 equals to 80. Second step is to find the differences from the mean. You have to subtract the mean from each score. Hence, 80 minus 80, 82 minus 80, 85 minus 80, and henceforth. Step 3 is to square each difference that we got in the last step. 0 square, 2 square, 5 square, and henceforth. Step 4 is to calculate variance. Variance is a measurement value used to find out how the data is spread across the mean or the average value of a dataset. For this, you calculate the mean of squared differences. You add the squared differences obtained in the last step, and you divide the sum by the number of scores. Hence, the variance is 58 divided by 5 equals to 11.6. In the last step, you take the square root of the variance. Hence, standard deviation is square root of 11.6, that is 3.41. This means that on an average, the test scores deviate from the mean score by about 3.41 points. Now let us see what is z-score or z-score. The z-score represents the number of standard deviations a data point is from the mean. To determine the z-score for a specific service level, you refer to a standard distribution table, also called the z-table, which we will be looking in the upcoming slides. To know more about normal distribution and z-score, you can refer to the text chapter given. Now let us understand how to calculate z-score. Step number 1 is to identify the service level. You need to determine the desired service level. The service level in relation to z-score determines the probability of not running out of stock during the lead time. Say we choose 96%. Now a question might arise that why can't we choose 100% and make sure that our inventory doesn't go out of stock even once. For keeping service levels at 100%, we have to keep extremely high safety stock, and there are chances that we are left with excess inventory if it doesn't get sold. Step 2 is to calculate z-score. It can be done in two ways. First is either to use a formula, or second is using a z-score table. So z-score table is a table that has numerous values of service levels. You need to find out the closest value to your selected service level, that is 0.96. Once spotted, you can see that there are two values, one in column and other in row. Here we have 1.7 in column and 0.05 in row. We will add these two values and get our z-score. Hence, our z-score is 1.7 plus 0.05 equals to 1.75. Now let us understand the calculation of safety stock. Assuming that we want a service level of 96%, which translates to z-score of 1.75, and we also assume that average demand during lead time is 100 units. Also, standard deviation of demand is 20 units and lead time is 2 weeks. Our safety stock will be calculated as 1.75 into 20 into square root of 2, which comes out to be 50.4. Rounding up, the safety stock needed would be approximately 50 units. What were the key takeaways of this video? We learned definition and importance of safety stock. And we also understood how to calculate safety stock. In the next video, we will discuss about reorder point. Thank you.